What if the very thing we thought was making artificial intelligence smarter, the relentless pursuit of more and more data, was actually its hidden Achilles heel, secretly sabotaging our most advanced machines? Imagine a world where the AI powering your daily conversations, diagnosing critical illnesses, and even navigating our increasingly complex digital lives begins to falter, not from a lack of information, but from an overwhelming surplus. This isn't a scene from a dystopian sci-fi flick. It's a stark warning emerging from the hallowed halls of academia, from the brightest minds at Carnegie Mellon, Stanford, Harvard, and Princeton. In a groundbreaking study released in March 2025, these titans of research have uncovered a phenomenon they've dubbed catastrophic overtraining, a deep structural flaw that could fundamentally upend how we design, build, and trust the AI systems that are rapidly becoming indispensable. Forget the occasional AI hallucination or a subtle bias creeping into an output. This is something far more insidious, a potential destabilizer for even the most formidable AI models like GPT-4, Gemini, and the generations yet to come. So, buckle up, because we're about to dive deep into a discovery that could redefine the future of intelligence, both artificial and our own. A team of brilliant researchers, spearheaded by the insightful Jacob Springer, hunched over glowing screens, surrounded by mountains of code and vast datasets. They were chasing a gnawing suspicion, a feeling that the fundamental tenet of AI, development, that more data and more training invariably lead to better performance, might be fundamentally flawed. Their findings, meticulously documented in a March 2025 paper on ARCS titled, "Overtrained Language Models Are Harder to Fine-Tune," sent seismic waves through the AI community. This paper challenged the very mantra that has driven the creation of AI GPT-4, Claude, and Llama, the idea that a bigger, more data-hungry model is inherently a better one. But what if this mantra, this unwavering faith in sheer volume, is actually a mirage? The researchers introduced the chilling concept of catastrophic overtraining to describe a phenomenon where feeding a model an excessive amount of data doesn't just lead to diminishing returns, it actively degrades its performance, making it worse. To truly grasp this, let's use an analogy from the culinary world, a realm many of us can relate to. Imagine you're preparing a complex gourmet dish. You've got all the right ingredients, a meticulous recipe, and you're aiming for perfection. But then, you get a bit too enthusiastic. You start adding more spices, more herbs, more of everything, convinced it will elevate the flavors. Instead of a symphony of taste, you end up with an over-seasoned, burnt, and utterly inedible mess. This is precisely what catastrophic overtraining does to AI models. The study revealed that beyond a certain threshold, large language models, LLMs, become significantly harder to fine-tune. Fine-tuning, remember, is the crucial process where these generalist models are adapted and specialized for specific tasks, like answering your customer service queries with precision, writing flawless code, or even composing a heartfelt poem. The truly alarming part? These overtrained models don't just plateau. They actively lose performance on practical, real-world tasks, even when presented with high-quality, relevant data. This isn't a minor bug or a quirky glitch. It's a fundamental architectural weakness that could be silently undermining the very AI systems we're increasingly relying on for our daily lives. Have you ever interacted with an AI assistant that, after a seemingly minor update, suddenly seemed less capable, forgetting how to follow simple instructions or struggling with tasks it previously handled with ease? You might have just experienced a glimpse of catastrophic overtraining in action. Let's delve into the rigorous experiments that expose this unsettling truth. To scientifically validate their revolutionary theory, the researchers turned their attention to a specific AI model, MO1B, a 1 billion parameter powerhouse developed by the Allen Institute for AI. Think of MO1B as a sophisticated, lab-grown AI organism large enough to realistically mimic the complexities of real-world AI systems, yet small enough to allow for precise, controlled experimentation. The team meticulously trained two versions of this model. The first was trained on an immense dataset of 2.3 trillion tokens, and in the world of AI, tokens are essentially the building blocks of text, akin to words, parts of words, or even punctuation. The second version received an even more staggering amount of data, a full 3 trillion tokens. This represented a substantial 30% increase in training data, a leap that, according to the prevailing wisdom, should have unequivocally resulted in a superior, more intelligent model. However, the results of their subsequent instruction tuning phase were nothing short of jaw-dropping, a complete inversion of all expectations. When they subjected both models to instruction tuning, the process of teaching them to understand and execute human prompts, the model that had been fed the larger dataset performed demonstrably worse. Across a battery of standard benchmarks designed to measure various AI capabilities, the overtrained model scored up to 3% lower than its less trained counterpart. It's a scenario many students can probably relate to. Imagine dedicating twice as much time to studying for an exam, only to perform worse because your brain has become too rigid, too locked into a specific way of thinking. The researchers were able to pinpoint a critical inflection point, a tipping point, at around 2.5 trillion tokens. Beyond this threshold, any further training didn't just fail to improve the model, it actively harmed its performance. The overtrained model exhibited a profound struggle to adapt, much like a dancer who has rehearsed a single routine so many times that they become incapable of learning a new dance. This wasn't an isolated incident or a statistical anomaly. This decline in performance was consistent and pervasive across a range of tasks, from answering complex questions to concisely summarizing lengthy texts. For anyone who uses AI, whether you're a student relying on it for research, a coder leveraging it for debugging, or a business owner automating processes, this discovery should serve as a glaring red flag. If the very tools you depend on are overtrained, they might not be as adaptable or as effective at meeting your unique needs as you believe. So, what exactly is going wrong inside the intricate architecture of these AI models that causes them to break down under the weight of too much data? The researchers unearthed the phenomenon they've termed progressive sensitivity. To visualize this, imagine an ice brain as an incredibly complex, interconnected web. Each connection within this web is meticulously tuned to recognize specific patterns in the data it's trained on, be it the nuances of grammar, the recall of factual information, or even the subtle cues that signal humor. As you continue to train the model, these intricate connections become increasingly rigid, locking into the precise patterns present in the training data. It's akin to over-rehearsing a speech to the point where you lose all ability to improvise or adapt to unexpected questions. You're bound by the script. When you then attempt to fine-tune the model for new, specialized tasks, like teaching it to write a compelling piece of poetry or to analyze sensitive medical records, even minor deviations from its ingrained patterns can disrupt this delicate, over-optimized balance. This disruption leads to what the researchers call forgetting. The model begins to lose skills it previously possessed, much like a master chef who, in their obsessive pursuit of mastering a cutting-edge molecular gastronomy technique, forgets how to prepare a simple, foundational sauce. For instance, an AI that was expertly fine-tuned to excel at writing complex code might suddenly find itself struggling with creative writing tasks, its newfound rigidity hindering its ability to shift gears. This is a particularly significant issue for the multi-purpose AI systems we interact with daily. These systems are expected to juggle a diverse array of tasks, from summarizing lengthy emails and generating detailed reports to assisting with complex medical problems. If you've ever noticed an AI tool that seemed to perform worse on one task at a recent update, this could very well be the reason. The more data we pour into these models, the more their internal structures become brittle, like a meticulously constructed house of cards that can collapse with the slightest tremor. For businesses that are investing millions, even billions of dollars into AI integration, this inherent fragility translates directly into the potential for wasted resources and the deployment of unreliable, underperforming tools. Now, let's bring these complex technical concepts down to a more tangible, everyday level. Chances are, you interact with AI multiple times a day. Whether you're asking Siri for directions, using ChatGPT to help draft an email, or relying on algorithms to recommend products you might like online, these systems are deeply embedded in our routines. The foundational models powering these interactions, such as OpenAI's GPT-4 and Google's Gemini, are trained on truly colossal datasets, with rumors suggesting these datasets can exceed an astronomical 10 trillion tokens. But if the findings of this catastrophic overtraining study are indeed universal, as the research strongly suggests, then many of these cutting-edge models might already be operating in a state of degraded performance, having long surpassed their optimal training thresholds. Consider the implications. Imagine a doctor, a highly trained professional, relying on an AI system to assist with patient diagnosis bias. What happens if, after the AI has been fine-tuned on a new database of medical images, it begins to lose some of its previously established diagnostic accuracy? Or think about a software developer who depends on an AI to help debug complex code. If that AI model has been overtrained, the developer might start receiving inconsistent or unreliable results, hindering their productivity. This isn't a problem confined to the giant tech corporations. Open-source AI models like Llama and Mistral, which are crucial tools for countless startups and academic researchers, are equally vulnerable. If you're a small business owner employing an AI chatbot to automate customer service, overtraining could mean that after an update, your chatbot starts delivering awkward, off-target responses that frustrate your customers. The study's findings paint a sobering picture. Every additional step in the fine-tuning process, every extra piece of data fed into an already overtrained model, could incrementally chip away at its effectiveness, akin to a sculptor meticulously sanding down a masterpiece until its original form and detail are lost. This reality directly challenges the industry's relentless obsession with scale, the drive for bigger models, more data, and longer training cycles. It's like chasing a mirage in the desert, believing that more of the same will lead to salvation, only to discover you built a machine that is fundamentally less adaptable and ultimately less useful. Let's address the colossal elephants in the room: GPT-4, Claude, Gemini, and their numerous brethren. These models are not just advancements in AI. They are the very bedrock of modern artificial intelligence, powering everything from our ubiquitous virtual assistants to the complex systems behind autonomous vehicles. However, the precise details of their training processes remain largely shrouded in corporate secrecy. Companies like OpenAI and Google guard their proprietary methods, rarely disclosing the exact number of tokens they utilize or where their critical inflection points for overtraining might lie. Yet, the stark findings of this new study offer a compelling hint. Models that have been trained on tens, or even hundreds, of trillions of tokens, as is widely believed to be the case for these leading AI systems, might very well be operating precariously within the danger zone of catastrophic overtraining. Have you ever experienced a subtle but noticeable shift in your favorite AI? Perhaps ChatGPT delivered an exceptionally brilliant, insightful answer one day, only to stumble over a seemingly simple question the next? Or maybe Claude, renowned for its robust safety protocols, suddenly struggle with a new application integration, exhibiting a peculiar lack of flexibility? These aren't necessarily isolated bugs or minor software glitches. They could be the telltale symptoms of models that have been pushed beyond their inherent adaptability limits. For instance, when OpenAI rolls out updates to ChatGPT, users frequently report that while the model might improve in logical reasoning, its creative capabilities seem to diminish. Similarly, Google's Gemini 1.5 Pro, widely praised for its ability to process and understand incredibly long text, has faced criticism for exhibiting inconsistent reasoning when it's fine-tuned for specific complex workflows. If catastrophic overtraining is indeed the culprit, then no amount of subsequent patching or minor adjustments can truly fix the underlying problem. It's akin to trying to unbake a cake. The fundamental chemistry has been altered, and you can't simply reverse the process. For tech companies that are investing billions of dollars into the development and deployment of AI, this discovery represents a profound wake-up call. And for you, the end user, it means that the AI tools you've come to rely on might not be as consistently reliable or as adaptable as you've been led to believe. The researchers, recognizing the profound implications of their discovery, didn't just stop at sounding the alarm. They actively delved into finding potential solutions. They rigorously tested various mitigation techniques, such as implementing lower learning rates, which essentially slows down the learning process, incorporating weight decay, a method to prevent individual data points from having too much influence, and meticulously curating the quality of the instruction data. These methods, while promising, acted more like a temporary band-aid on a potentially catastrophic problem, like reinforcing a dam with sandbags. They could delay the onset of degradation, but they couldn't entirely prevent it. Models that were trained beyond the critical 2.5 trillion token threshold consistently underperformed after the fine-tuning process, regardless of these interventions. It's like attempting to teach an actor who has over-rehearsed their lines to improvise. No matter how carefully you coach them, they remain locked into their rigid performance. This reality throws up a series of crucial questions for the future of AI development. Could entirely different training algorithms, perhaps switching from the commonly used ADAM optimizer to a newer approach like Lion, effectively circumvent this overtraining issue? Might the sheer quality of the data, rather than its quantity, be the true determinant of a model's long-term adaptability? Researchers at prestigious institutions like ETH Zurich and UC Berkeley are already actively exploring these avenues, investigating whether novel model architectures, such as the increasingly popular mixture of experts, mole models, could be inherently more resistant to this flaw. However, for the immediate future, there appears to be no simple solution, no silver bullet that can magically fix catastrophic overtraining. This leaves AI developers at a stark, difficult choice. Should they focus on building immensely powerful base models that might inherently resist fine-tuning? Or should they prioritize adaptability and flexibility, potentially at the cost of raw, unbridled processing power? For you, the user, this might translate into making more conscious choices about the AI tools you adopt, perhaps opting for customizable, open-source models that offer greater control over their behavior, rather than settling for one-size-fits-all, proprietary giants that might be less adaptable to your specific needs. This groundbreaking discovery arrives at a pivotal moment in the evolution of artificial intelligence. The global AI race is intensifying by the day, with nations and corporations alike pouring billions into the development of ever larger models and increasingly lengthy training regimes. However, the warning about catastrophic overtraining fundamentally flips this narrative on its head. The focus, it seems, can no longer solely be on sheer scale. Stability and adaptability are emerging as equally, if not more, critical factors. In sensitive fields like healthcare, where AI is being developed to analyze X-rays and assist in diagnosis, or in education, where it's used to personalize learning experiences for students, the ability to fine-tune and adapt these models without breaking them is paramount. If AI models cannot be reliably fine-tuned for specific applications without degrading their performance, their practical utility diminishes significantly. Imagine an AI tutor that excels at teaching advanced mathematics but, after a routine update, forgets how to explain fundamental historical concepts. That's the very real risk we are now facing. For you, the individual navigating this rapidly evolving landscape, this discovery necessitates a more informed and discerning approach to the AI you use. The next time you interact with an AI tool, it's a chatbot, a creative writing assistant, or a data analysis platform, pay attention. Notice if it exhibits peculiar behavior after an update. or if it feels unusually rigid or inflexible when you try to guide it towards a specific task. If you're a business owner, consider shifting your investment strategy towards AI solutions that are explicitly designed for flexibility and adaptability, rather than simply prioritizing raw computational power. For AI developers and researchers, this is a clear mandate to rethink and innovate training strategies. Perhaps the future lies not in ever larger datasets, but in smaller, more intelligently curated, and highly diverse datasets. The true future of artificial intelligence will undoubtedly hinge on our ability to strike a delicate balance between raw capability and the crucial ability to adapt and evolve. Much like a world-class gymnast who possesses immense strength, but also the nimbleness to perform breathtaking maneuvers. So, what is the ultimate takeaway from this bombshell that's shaking the foundations of the tech world? It's a profound reminder that, in many aspects of life, more isn't always better. Just as in our personal lives, piling on too much, whether it's work commitments, social obligations, or even excessive amounts of data, can ultimately backfire if we don't understand the crucial point at which to stop or to change our approach. Think about your own experiences. Have you ever over-prepared for a situation, meticulously rehearsing every possible scenario, only to find yourself feeling rigid and unable to adapt when the unexpected inevitably occurred? The same fundamental principle applies directly to the development and deployment of artificial intelligence. The core lesson here is the pursuit of balance. For AI developers, this means diligently searching for that sweet spot in the training process, the optimal point where a model is powerful yet still retains its crucial adaptability. For you, as an end user, it means making informed choices about the AI tools you integrate into your life, selecting those that genuinely evolve with your changing needs, and, perhaps most importantly, remaining curious and open to understanding how these powerful technologies actually work. So, what are your thoughts on this revelation? Have you personally noticed AI tools acting strangely or becoming less capable after updates? Do you believe the current race for ever larger AI models is a worthwhile pursuit despite the risks, or should our focus shift towards developing smarter, more efficient AI, even if it means smaller datasets? I genuinely love to hear your perspectives and engage in a thoughtful discussion in the comments section below. If you found this deep dive into a hidden flaw as fascinating and thought-provoking as I did, please consider hitting that subscribe button to ensure you don't miss out on more stories that challenge your assumptions and spark your curiosity. Wishing you all good health, continued curiosity, and a balanced approach to both technology and life. I look forward to connecting with you in the next one.